Hello, and welcome to this lesson on producing potable water. In today's lesson, we'll begin by describing the typical steps involved in producing potable water, including source selection, filtration, and sterilisation. We'll then spend some time identifying common sterilisation agents used in water treatment and explain their mechanisms of action. Finally, we'll touch on how these methods vary according to the water source. So far, we've explored the concept of potable water and its significance for humans, emphasizing the need for safe, drinkable water in our daily lives. Building on this foundation, today's lesson will deepen our understanding of the processes and chemical principles involved in turning raw water into potable water. Through this, we'll gain insights into the role of chemistry in ensuring the safety and quality of the water we consume. Let's get started! The first step of producing potable water is source selection. Water used for drinking is typically sourced from freshwater bodies such as lakes, rivers, or groundwater. When selecting a water source, it's important to evaluate the quality and availability of the water. Factors influencing this choice include the level of contaminants, the amount of water available, and regional geographic considerations. Once a suitable water source is selected, the next step is filtration. Filtration helps to remove suspended particles, sediment, and larger impurities from the water. This process usually involves passing the water through filter beds composed of layers of sand, gravel, and activated carbon. Each of these layers serves a unique purpose. Sand and gravel physically trap larger particles and sediment. Activated carbon helps to remove unwanted tastes, odors, and some chemicals through adsorption. By the end of the filtration process, the water is clearer but still may contain harmful microorganisms. The third step is sterilisation, where the aim is to kill or deactivate harmful microorganisms. Common sterilisation agents used in water treatment include chlorine, ozone, and ultraviolet light. Let's explore how each of these works. First, chlorination. Chlorine is added to water because it is a powerful disinfectant. It works by penetrating the cell walls of microorganisms and disrupting their internal functions, effectively killing bacteria and viruses. Chlorination also provides residual protection, meaning it continues to disinfect as the water travels through pipes. Ozonation is another option. Ozone is a strong oxidizing agent. When dissolved in water, ozone breaks down into oxygen and atomic oxygen. The atomic oxygen is highly reactive and destroys microorganisms by oxidizing their cell walls. Ozonation is very effective and leaves no residue in the water. UV light sterilization involves exposing water to UV rays. UV light damages the DNA and cellular structures of microorganisms, rendering them inactive and unable to reproduce. This method is effective without adding chemicals and does not leave any residue. Let's look at deciding which treatment is used. The specific treatment techniques chosen can vary depending on the initial quality of the water source, regional factors, and available infrastructure. For instance, areas with high levels of industrial pollutants might require additional treatment steps to remove specific contaminants. In contrast, regions with limited resources might rely on simpler, more accessible methods. Now that we've looked at the conventional methods for producing potable water, we'll soon explore desalination, particularly relevant for areas lacking fresh water sources. Remember, these steps, source selection, filtration, and sterilisation, are integral for ensuring that water is safe to drink, providing an essential service that supports public health and well-being. Now, for some extension knowledge, let's take a closer look at global water scarcity. Did you know that only 0.5% of all the water on Earth is fresh water that we can actually use? That's it, just 0.5%. Over the last 20 years, the amount of water stored on land, including in snow, ice, and soil, has been dropping by about 1 centimeter per year. This means the water systems that support ecosystems and provide for our growing population are under serious stress. Rivers, lakes, and aquifers are drying up or becoming too polluted to use. Over half of the world's wetlands have already disappeared. Now think about this. 2 billion people, which is 26% of the global population, don't have access to safe drinking water. On top of that, 2.7 billion people, 36%, experience water scarcity for at least 1 month every year. And unfortunately, this number is only going to increase. One striking example is Cape Town, South Africa, which faced a major water crisis between 2015 and 2020. A combination of severe drought and a growing population caused the city's reservoirs to drop to dangerously low levels. In 2018, the situation became so critical that the government warned about the possibility of day zero, the day the municipal water supply would be turned off. It would have been the first major city in the world to reach this point. Thankfully, Cape Town avoided a total shutdown by implementing strict water conservation measures. The city treated and recycled wastewater for reuse in irrigation and industry, built desalination plants, and encouraged residents to use water sparingly. These efforts highlight the importance of water conservation and management, especially in areas facing the dual challenges of climate change and population growth. This is a global issue, and as the demand for water increases, it's clear that sustainable water management is more critical than ever. In today's lesson, we delved into the process of producing potable water, essential for ensuring safe drinking water. This lesson provided a comprehensive understanding of the steps involved in making water potable, including common sterilisation agents and how methods vary by source. Overall, highlighting the crucial role of chemistry in maintaining public health. Watch the rest of the GCSE chemistry course at Sophos Education.